Hello and welcome to my GCSE Science. This is the first video in topic 7 on organic chemistry, and it's all about crude oil and alkanes. If you're studying double science, there's only 2 videos in this topic that you need to watch, as most of it is for triple science. But this first one is for everyone. So, what is crude oil? Well, crude oil is a non-renewable resource. This means that it's going to run out one day. And it could be one day very soon if we keep using it at the rate we're using it. We can't just make some more, because it's made from the ancient remains of sea creatures, especially plankton, that were buried millions of years ago under the sea. And this is why crude oil is called a fossil fuel. Rather than just being one substance, crude oil is actually a mixture of a really large number of compounds, mainly hydrocarbons. Hydrocarbons are really important compounds, and they're made up of only hydrogen and carbon. The majority of the hydrocarbons found in crude oil are called alkanes. And these are particular kinds of hydrocarbons where all of the carbon-carbon bonds are single covalent bonds. For this reason, they call them saturated hydrocarbons. Saturated because no more hydrogen atoms can be added. So we said that hydrocarbons only had carbon and hydrogen in them. So let's have a look at how these are arranged in alkanes. All alkanes have the general formula CnH2n plus 2. That means if we have n carbons, then there's going to be 2n plus 2 hydrogens. The 4 examples that you need to know about are these 4 here. Methane containing 1 carbon, ethane containing 2 carbons, propane containing 3 carbons, and butane containing 4 carbons. So if we follow the general formula, if there's 1 carbon, then n equals 1. So 2n equals 2, and 2n plus 2 equals 4, which gives us methane with the formula CH4. As well as being able to write the equation like this, you'd also be expected to draw out the displayed formula, which looks like this. This is exactly the same as above, except that it shows all of the bonds in the molecule. Each one of these, if you think back to topic 2 on bonding, represents one covalent bond. Based on this, have a go at doing the displayed formula for ethane, propane and butane and see if you can do it before I show you how. So for ethane we have 2 carbons and 6 hydrogens. So that's 2 carbons with a single bond, and then we have hydrogens all around propane and butane. You may have noticed an important feature of the bonding in hydrocarbons. Each hydrogen can only have 1 bond. This is because it only has 1 electron it can share in a covalent bond. But each carbon makes 4 bonds. In this case, each of the bonds is with a hydrogen, but in later videos you may see carbon making bonds with other atoms, such as oxygen, or even double bonds with other carbons. But it's really important when you're drawing these displayed formula, or structural formula they're sometimes called, that you count the number of bonds, because it's quite a common mistake to either draw 5 bonds around a carbon or 3 bonds, and that's not correct, so you might lose marks on it. So after drawing one of these, always check that hydrogen has 1 bond and carbon has 4 bonds. So we mentioned alkanes because this is the family of molecule that's most common in crude oil. And crude oil is really useful because the hydrocarbons that are found in it can be used for a great variety of different uses. As we said, crude oil is a mixture, and so to get these different hydrocarbons out of it, we need to use a method of separation called fractional distillation. We touched on this briefly in the very first topic, but we're going to look at it in a little bit more detail here. This is what we would call a fractional distillation column. At the bottom of the chamber, hot crude oil is pumped in, and it's so hot that most of it is a vapour. So as it gets pumped in, the bottom of the chamber contains the hottest gases. And here the first fraction, bitumen, which has the highest boiling point, gets tapped off because it becomes a liquid at a really high temperature. the hot gases rise up through the chamber, and as they rise up, they cool down. So at the top here we have the coolest part of the chamber, which means that the hydrocarbons with the lowest boiling point get tapped off here. That would be what would be known as LPG, liquid petroleum gas, or bottled gas that you might find in your stove or in a camping fire, like propane, for example. In between, the rest of the compounds get separated according to their boiling points, and they get separated out in groups called fractions, which have different ranges of boiling point. So as the hot gases rise up the chamber, at each stage some of the gases will start to condense depending on their boiling point. You may be expected to give examples of these fractions, or examples of what they might be used for. So we've mentioned bitumen already, which is often used for tarring roads, and we've mentioned LPG, or bottled gas, which as we said is used for campfires or gas stoves at home. Down here we have fuel oil. This is quite a thick and sticky oil which has a very high boiling point, and it's normally burnt in big factories or ships to produce heat or to make engines run. It's not particularly efficient. Next we have diesel, which is used to power some cars, but most commonly to power large trucks or lorries. Then we have the kerosene fraction, which if you've been to countries in the developing world is actually used in lanterns, and it would have been used in the Victorian times here as well. But nowadays hydrocarbons within this fraction are often used for aircraft fuel. Then we have the naphtha fraction, which is commonly used in the chemical industry to make starting chemicals for other things such as plastics, dyes, drugs, explosives and paints. And there's a special term for this, which is chemical feedstock. Finally, we have the petrol fraction, which has a relatively low boiling point, and that's obviously used as fuel in cars. It's very unlikely that you'd be asked to name all of the different fractions and all of the different uses, but it is important that you're aware of what types of uses these substances can have. But the key thing to know about this process is the fact that these different fractions are separated based on their different boiling points, and that at the start we have hot vaporized crude oil, and at each stage at the specific different boiling points the gases condense into liquids which are tapped off at these different levels. The liquids with the highest boiling points will condense at the bottom, and the liquids with the lowest boiling points will condense at the top. So this idea of evaporation at the beginning and condensation as the gases rise up the chamber is really important. We've already mentioned some properties and uses of hydrocarbons, but one thing that I think is really important is to be able to link their properties and uses to the length of the molecules. So the first key thing is that molecules with different lengths have different boiling points. And the smaller the molecule, the fewer atoms are in the molecule, the lower the boiling point will be. And the longer the molecule that contains many atoms, the higher the boiling point will be. So if we quickly look back at the fractional distillation column, we can see that the fractions which have a high boiling point are fractions which have very long molecules, and the fractions which have low boiling points are fractions which have much smaller molecules. And in fact, if you think back even further, this is the fraction that contains the alkanes we looked at earlier, which is methane, ethane, propane and butane. These are the alkanes that exist as gases, but we do have alkanes which are larger and therefore have higher boiling points, and some are even liquids. Okay, so the longer the molecule, the higher the boiling point. That there are other properties that change with the length of the molecule. The property called viscosity is to do with how runny or sticky something is. So something with a lower viscosity is quite a runny liquid, and something with a high viscosity is quite a sticky liquid like honey. So the short molecules are quite runny, and the longer molecules will be quite sticky as liquids. You may know what flammability means. This is how easily a substance will catch fire. The shorter molecules are more flammable, and the longer the molecule gets, the less flammable they become. This means that the hydrocarbons which are more like gases are much more flammable than the ones that are liquid, and some, like candle wax for example, are solid, And while you think of candle wax as being quite flammable, it's actually relatively unflammable compared to things like petrol and LPG and the propane gas that comes out of your camping stoves or the methane gas that comes out of your gas taps at school. Finally, there's a property called volatility, which is to do with how easily a liquid turns to a gas. Very much like flammability, some of the really small molecules are already gases. As they get longer, we get liquids that turn into gases quite easily. Then we get liquids that don't turn into gases very easily. And finally, we have solids which have to first be melted into liquids before they can then turn into gases. So the longer the molecule, the less volatile, meaning the less easily they'll turn into gases. That's all for this first video on crude oil and alkanes. Here are a few keywords for you. We covered quite a lot in this video. The three main things to take away are what alkanes are and how to draw these four main alkanes, what crude oil is and how it is separated using fractional distillation, and some of the properties and uses of the different fractions that come out of crude oil. I hope you feel you've learnt something from this video. The next video is on combustion of hydrocarbons. Hope to see you there.